All right, ladies and gentlemen, welcome to Forces 2, Lesson 4.1, How Do Forces Act with Fluids? And so I use the term fluids to describe a new type of force. Up until this point, we've been working with solids and how forces act on those, but we're going to be talking about fluids today. And so you might have heard from a doctor saying to you, if you're dehydrated or in the summertime, you might see the weatherman say this, you gotta drink your fluids. And so a lot of times we think of fluids as like, a drink of water that we have, that we drink, and we need to make sure we're hydrated and everything's great with that, or else, we kind of die because we need our fluids. Well, basically, in the science world, fluids is a little bit more of an expansive term. It's a little bit bigger, and it includes anything that can flow. The term flow just simply means that the molecules are free to move either in a confined space or, they're free to bump into each other and flow in those directions. We talked about viscosity, the resistance to flow as well. And so liquids most definitely fit that term, but also I want to contend that in the science world, gases also are a part of that. And so they are actually able to flow as well. We can move them and we can push them and help them, or they can actually help us do work. And so they also, influence our everyday lives as well. And so we're going to be talking about how that force of fluids can actually impacts our world, as well as we can use it to do work. Another term that we're going to be talking about, we talked about force, the push or pull. Fluids are liquids and gases, and pressure is the amount of force exerted by fluids. And so it's the collision and the pushing of particles on each other and on its container. And so we understand that fluids are not only liquids, but also gases too, and that a force is a push or a pull. So if you might have done this before where you see smoke from a fire and you're trying to swat at it, where does the force of where does the smoke go? It kind of goes in all these crazy directions that you'll see it go away from your hand. And so think about how does water act when you swim and all those different things there. It doesn't really go exactly where you push, but it kind of goes around your hand as well as with you. And so they're kind of just flowing around you, and so you get that idea also with wings. If you could imagine this as like the wing of an airplane, and so the gas particles actually go around it, and we call that idea that the resistance against air, lessening that is called like aerodynamics, and we want to make sure that we get a least amount of friction in fluids as well. So fluids act that way, and because they are less attached, if I think about it, a solid is just all attached together. I can equate that to like a puck in hockey. And so solid particles are compact and rigid, so they act in the direction of the force, whereas liquids, if I push on fluids, if I push on a balloon, it's not going to put that same exact force on the other side of it. It's actually going to go in all directions. And so the same thing happens with water. We learned about that with water displacement. When a rock is dropped, we don't see the water just simply push out onto the bottom, but also it goes onto the outsides of the container as well as on the rock itself. And so we see all those different parts there involved with fluids as well. So here's a scenario. You're blowing up the balloon, and you keep blowing up that balloon, and eventually it pops. Or you accidentally let it go, and you see it fly in all different directions. Well, why does it do that? Where do forces act, and where do these particles go? And to understand that, we need to remember what pressure is. It's simply the collision of fluids and their molecules on the outside of the container as well as on themselves. And so inside your balloon, you're seeing these particles pushing on the container as well as on each other in all these different directions. And so that pressure is also pushing this balloon, this surface, outward. But there's also a pressure of these oxygen molecules and other gases like hydrogen, nitrogen, and smokes and carcinogens in the air and all those different things. of exhaust and everything else. So we have all that other stuff pushing in on the container as well, the atmospheric pressure. And so how does this balloon decide to move out? Because we have two forces going against each other, just like with law 3. And the idea is that there is an unbalanced force. Okay, and so when there's an unbalanced force, the motion goes in the direction of the greater force, wherever that's going. And so if this balloon is going outward, you got to think, where is the greater force? Is it in here? Or is it out here? And if it's pushing outward, that means the force is actually greater on the inside. That means there is more pressure on the inside than there is on the outside of the balloon. And so eventually you keep blowing up that balloon and blowing up that balloon, and then there's more pressure and more pressure building up. It expands and it expands, and boom. It goes everywhere. And you get this balloon that ends up dying. And, you know, it becomes just a mess of plastic. And so eventually that's because the force of the inside is too great for the balloon to handle. And so this gives us a great insight as to how do forces act in fluids. Forces in fluids for pressure is that they flow from areas of high pressure to areas of low pressure. Okay, so think about what that means. With the balloon, it was going from areas of high when you let it go to areas of low. So when you have the balloon, when you let it go, all that air that's in here is being pushed outward to areas of lower pressure. When you have a vacuum, it's going into the vacuum because there's being air pushed out of it. So there's going from areas of high pressure outside the atmospheric pressure to areas of low pressure inside the vacuum. So a vacuum is just simply movement of fluids. And so you actually just have a lack of pressure. That's all that really means. And so same thing with this. You have the pressure of the air pushing into your pushing into the bike pump, and so you have this bike pump, and it pushes the air into the tire. And same thing with the liquids in the hydrant, the faucet, and the spring of the pond here, and the spigot. Okay, there's areas of pressure that are pushing upward so that it can flow outward into areas of lower pressure. Same thing with geysers, volcanoes, Old Faithful at national parks. So basically, this idea of high to low also deals with weather too. We see high pressure and areas of low pressure where we see storms and everything like that. And so this idea of pressure, it pretty much impacts everything that we do and what we see on an everyday basis. And so I want you to think about some ways that it impacts your life and some ways that it does that for you. So we're going to recap and finish up for today's quick vid. And so to recap with forces, forces act in fluids. A fluid is just simply a liquid or gas. Pressure is the amount of force exerted by those fluids. Our next videos that we're going to be doing are going to be that we calculate pressure and seeing how much pressure an object is having and containing. And we're also going to be looking at different ways that we use fluids to do work. And so there are two fluids, and so we're going to be looking at different types of devices for that.